Y'all had some time to look at the warm-up? Can you conclude the following? So we're using this little sheet that we got yesterday to decide if we are allowed to assume or if we're not allowed to assume. So let's look at number 1. Avi, what'd you get for number 1? Assume or not assume? Not assume. AB is congruent to BC. If you don't see tick marks on your picture, then you definitely cannot assume. So this one's a no. What would we add to the picture to show that they're congruent? We would add tick marks if we wanted to show that they're congruent. All right, number 2. Quinn. Good. The fact that GH is perpendicular to CD, we also can't assume that, even though students love to assume that because they're like, that was drawn with a computer, it looks perfect, it's exactly 90 degrees. But if there's no box there, if there's no 90-degree indicator, then you cannot assume as much as you would love to. V, number 3. I think I always call you for number 3 because that rhymes. No, AJ is greater than JD. I realize that in the picture, AJ looks much greater than JD, but on our list, we are not allowed to assume relative sizes of points. That's a relative size, that something's bigger than the other. So without knowing that their actual length, we can't assume that one. All right, next up, Alexandria. Number 4. AJ is greater than AC. Now, this one's a little bit different. I was a little tricky. We can't assume number 3. But we can assume number 4. We can. Because you have to look at the picture. AJ is greater than AC. One thing we can assume is collinearity of points. Those points are collinear. And C is between A and J. So the distance from A to get all the way to J has got to be longer than the distance from A to C. They are collinear. You are allowed to assume collinearity. I just like saying that word. All right, next up is Ariana, number 5. Yes, we can assume collinearity once again. Very good. Okay, Abbas, next one, number 6. Number 6. Very good. That's another no. You're not allowed to assume midpoint. How would we know it's a midpoint? There would have to be tick marks on either side. And I don't know if I've talked about this before, but if you've already used one tick mark and you want to show something else is congruent, then you use a double tick mark. The same thing goes for angles, just FYI while we're talking about it. The same thing goes for angles. If I want to show these 2 angles are congruent, I put an arc. But if I want to show another pair of angles are congruent, we put a double arc. And then it looks like a fun picture. All right, let's check that homework because that's always what we do next. We check the homework. Let's move on to the next page of answers. How'd you do on the assume, not assume at the bottom there? Not so bad? Yes, Adriel, this is the homework answers. It was called Angles and Assumptions, I think. Angle and Assumption Practice. Okay, so I'm going to go over number 15 and number 21. Number 15, name a pair of vertical angles. So remember, vertical angles, let's see, does this let me, yeah, okay. Vertical angles are angles formed when you have the letter X. When you have 2 lines crossing, that's when you get vertical angles. So an example would be AOB and DOC. That's one pair of vertical angles, those green ones. Another pair of vertical angles, let's see, would be BOC and AOD. Sorry, that's kind of ugly. Those huge ones, BOC and AOD. So you can pick the really two acute little ones, those little ones, or you can pick the huge obtuse ones that are the linear pair of the acute ones. Okay? So that was number 15, vertical angles. And remember, vertical angles are always congruent. And then number 21, can you make each conclusion from the information in the diagram? Okay, 21, can you make each conclusion explain? So 21 says JAC and DAC are congruent. So Anna, what it was talking about, some of the things on the pictures have markings and some don't. Anna, do you see angle J and angle D? Do you see how they have those arcs on them? Those are congruent because they have a marking, because they have arcs. Do you see an arc on JAC and DAC? There's no markings. It's empty. It's blank. And that's why we can't assume that one, whereas we can assume this one. We're using the markings they gave us on the picture. Sometimes there's tick marks and sometimes there aren't. Sometimes there's arcs and sometimes there's not. Okay? The good news about this lesson is that we've already learned it. We've already learned it in the form of segment addition and midpoint. Instead, I'm going to change two words. Instead of segment addition, it's going to be angle addition, and instead of midpoint, it's going to be angle bisector. So angle addition and angle bisector is what we're learning about today. But we've already learned it, so this is kind of old news. Sure, yeah, it'll be easy, yeah. If point B is in the interior of angle AOC, then, if I take an angle and I put a point anywhere in the interior, it does not have to be in the middle. I can move this point around and this statement is still going to be true. Then, I'm going to connect O to B, if you don't mind, with a ray. Here's our postulate, or our theorem. If B is in the interior of AOC, then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. That's pretty much just like saying part plus part equals whole. And that's what we already learned with segment addition. So, in a nutshell, that is angle addition. Part plus part equals whole. So really, we're doing the same thing that we did, except we have angles this time. Please always label your picture. When you are given information like that, please don't try to solve without first putting it in your diagram. Okay, measure of angle AOB is 17x plus 1. Measure of angle BOC is 7x plus 5. And the measure of angle AOC is 150 degrees. So these all represent degrees of angles. So we know that when we add, the theorem says, if we add AOB plus BOC, we're going to get AOC. Part plus part equals whole. And the rest is algebra. Combine like terms. 24x plus 6 equals 150. Subtract 6. Divide by 24. What'd you get, Dustin? All right. X equals 6. It didn't even ask us to find anything, did it? Woo! Okay, well, let's find the missing angle measures, okay? So x equals 6, and let's plug it back in to find the missing angle measures. So, Ganesh, tell me what AOB equals, and Graham, tell me what BOC equals. Okay, Graham, for BOC, you got 47? So it's a 47-degree angle. And good, Ganesh, for AOB we have 103. But you know, once you plug it into one of them, you could just subtract it from 150 to find the other one, right? Okay, very good. Simple, basic problem. Next one. AOC, uh-oh, I gave you the whole first, be careful. AOC is x squared minus 5, AOB is 35, and BOC is 6x. Find the measure of AOC. I'll give you a little bit of time to work on that one. 95 for AOC, and x is negative 10 and 4. All right, let's set it up. Let's set it up. Part plus part equals whole. So we've got 6x plus 35 equals x squared minus 5. We know in a factoring problem you have to set it equal to 0. So we're going to bring everything over to the right. We're going to say 0 equals x squared minus 6x minus 40. Did we all at least get that far? I'll talk about it just a second. X squared minus 6x minus 40. Okay, so then we need to do our factors. We need things that multiply to get 40. So on and so forth. Multiply to get 40, but combine or subtract to get 6. And our winners would be 4 and 10, so very good. 4 and 10. We want a negative 6, so we want our larger number to be negative. So we're going to have a 4 and a negative 10. So actually what you said, it's going to be the opposite of what you said. So we're going to set these equal to 0. And x equals negative 4. And x equals 10. Are we okay with that? Now we have to decide whether we keep one of them or we keep both of them. One of the answers is always going to work. So you're asking, what if they're both negative? Well, one of them, when you plug it in, will work. Sometimes both of them will work. And we have to decide. So in this one, if we plug 10 in to AOC, if we plug 10 in, we get 100 minus 5. Wonderful. It's 95. That works. If we plug negative 4 in, we have to be careful because that one actually also works too. Negative 4 squared is 16. 16 minus 5 is 11. But be careful, just because it works here doesn't mean it works everywhere. A negative would not work in angle BOC. We don't do negative angles in this class. Angles do not have a negative measure in this class, and so therefore we have to throw this one out. Sometimes we keep it, sometimes we throw it out. This time we throw it out. Okay, so 10 is the one that works. 10 is the x value that we use, and the answer is 95. Next part of the lesson. Midpoint is to segment, as angle bisector is to angle. It was 10, yes. So an angle bisector, it is a ray, because an angle is made up of rays. So an angle bisector is a ray that divides an angle into two congruent angles. So that is the definition of an angle bisector. So notice how I said ray BD, because it's a ray BD bisects angle ABC. Okay? Here are all the situations that we could throw at you in this lesson. 3 situations. I want you to stare at those situations. I don't need you to solve them. I just need you to decide how you would set each one up. Because setting it up is half the battle. It's most of the battle, actually. So, in this picture, if we have arcs on our picture, that means the angles are congruent. If we don't have arcs on our picture, that means you cannot assume the angles are congruent. So let's talk about what we would do in the first situation. This is an angle bisector. That symbol means bisector, by the way, B with a circle, lowercase b. Since it's an angle bisector and I gave you the half and the half, you would set the half equal to the half. Situation number 2. This is also an angle bisector, except I didn't give you the half and the half. I gave you the half and the whole. We already did this last unit, but I would not set 3x equal to 54. I would not do that. I could set 6x equal to 54. Or I could do 54 divided by 2, and I could set 3x equal to 27. Two choices. Okay, next one. This is not an angle bisector. So in this one, you would do part plus part equals whole. And we're not really going to solve it. I just want you to know how to set up each problem. So when you get a problem, first ask yourself, is this an angle addition problem or a bisector problem? All right, let's try this one. Ray MO bisects angle LMN. Angle OMN is 2x plus 14. Angle LMO is 4x minus 2. Solve for the missing parts. We need to label our picture first. MO is the bisector, so I would label that first. MO is the bisector. And then I can put the L and the N wherever I want, because it doesn't matter where those go. OMN is 2x plus 14. LMO is 4x minus 2. I forgot something very important. Since MO is a bisector, what symbol should I add to my picture? Arcs. Arc, arc. Makes me think of a seal when I say that, like arc, arc, arc. Anyways, all right, you add arcs to your picture. Oh, I've got arcs. I've got the half and the half. They're perfectly equal. They're the exact same angle. Therefore, I can set them equal. 4x minus 2 equals 2x plus 14. And now this is super easy. Rishi, when you have your answer, can you type it in the chat? Okay, so x is 8. Are we okay with x being 8? So I was saying, now here's the deal. Angle LMN is the whole angle. So what you can do is you can just plug 8 in wherever you want. 2 times 8 plus 14. But then be careful, because that's only half the angle. So if you plug it in, you would get 30. But you know that these are congruent. So that one's also 30. So there you go. Angle LMN is 60. Let me say something that I haven't said yet. When you see this M here, right here, that means the measure of angle LMN. You actually are not supposed to put degrees on your answer. You're not supposed to put a degree symbol. Because when it asks for the measure of angle LMN, that implies that you're already finding the degree of an angle. So actually putting a degree symbol would be redundant. So I actually, on purpose, I do not put degree symbols if there's a little M there, just to let you know. Now, on my picture, did I put degrees? Yes, I put it on my picture, but not when you're asking for the measure of an angle, because that's being redundant. All right, next one. OB bisects AOC. What's the first thing you should do? Arc, arc. Measure of angle BOC is 4x plus 1. Measure of AOC is 98. So here we go. I'm giving you the half and I'm giving you the whole. So you definitely don't set them equal. Yay, awesome. We wouldn't say 4x plus 1 equals 98. We would say 8x plus 2 equals 98. Lars, can you tell me what x is? Subtract 2 and divide by 8. 96 divided by 8. Thank you, Abbas. 12. All right, we're going to move on. We could plug it in and we could find the values, but we don't need to. All right, just for fun, everyone, well, you can't really stand up and find a partner, but how about on your picture, sketch vertical angles real quick. What do vertical angles look like? Go. So you should be drawing two lines crossing, and then vertical angles would be like 1 and 2. Because I can't make you stand up and make vertical angles in the classroom. All right, draw me a picture of complementary angles. Draw a picture of complementary angles. Can't really draw it in the chat, so you're drawing on your paper. Hopefully you're drawing something like this. Angle 1 and 2 are complementary angles. Remember, it's right to give a complement. So complementary angles together, they sum to 90 degrees, a right angle. An L, there you go. Supplementary angles. Y'all are doing a K? A K wouldn't really work. You couldn't do the letter K because supplementary are two angles that add to equal 180. So it would look more like that. That's not really a K. That's like a slanted upside down T. You could do a T. A T would work. A T would be a better representation of supplementary than K would. All right. Adjacent angles that are not complementary or supplementary. Adjacent angles. Ooh, that one was good, but those were supplementary. So adjacent angles are just angles that are right next to each other. I didn't want them to add up to 90 or 180. Mine's pretty close to adding up to 90, but pretend it doesn't. W, oh, a W is kind of a good idea. Okay. A linear pair. I already drew a linear pair when I drew supplementary. So supplementary, I could have drawn like this and then this. And I could have called it like 130 and 50. But for a linear pair, you can't separate them. You would have to make sure that you draw them next to each other, forming a straight line. All right, always mark your picture with the given information. AC bisects angle bad. So I would immediately add arcs to my picture. DG is perpendicular to BE. So I would immediately add right angle markings. And you get to add 4 of them, because when two lines are perpendicular, you have 4 right angles. And now we just need to find some missing information. Let's fill in some numbers on our picture, because right now our picture doesn't have any numbers. If I take 90 and I bisect it, what do I get? Hopefully you're saying 45. Wonderful. And then don't you agree that because these are vertical angles, that this would be 45, and therefore that would make also this one 45 because of vertical angles. Okay, let's stop talking about that and let's find the measures of these angles. GAB. GAB. So follow it from G to A to B. It's this purple angle right here. We've got a 90-degree angle. CAD, we already filled that in, 45. GAF, we already filled that one in, we're doing good, 45. And FAD, FAD. This one is this obtuse angle right here. This is angle addition. You would need to do 90 plus 45. So make sure you grab that whole angle. It's obtuse and you had to add things together. Okay. Another one. 2 is perpendicular to B. To be or not to be. All right, so if it's perpendicular, you can add your 90-degree angles, 4 of them. So how would we solve for X? There you go. 4x minus 2 is 90 because that is a right angle. It's 90 degrees. 4x is 92. x is 23, and the measure of angle 1 would be 90. Sorry, I'm going quickly because I know y'all are leaving. Ooh, what would we do on this one? Now, do you agree that if this is a straight line, it's 180 degrees? And if that's 180 degrees, and I've already used up 90, 180 minus 90 is always going to be 90. So if you have a right angle, and it's a linear pair, you're always going to have another right angle right next to it, okay? Those DB is perpendicular to AC. So how would we solve this one? This is 90 degrees, and we would do part plus part equals whole. Here's what you would not do on this one. 3x equals x squared minus 10. Because no one told us that was an angle bisector. That's when you're not allowed to assume, so be careful. So 4x squared minus 10 equals 90. Because I added those together, I hope that's okay. 4x squared equals 100. X squared equals 25. And x equals plus or minus 5. We actually get to keep both answers, because if we plug 5 in, it works, and if we plug negative 5 in, it also works. So this time we do keep both answers. Okay, and then we would just literally plug it back in to find our missing ones, okay? I know that y'all are leaving, so we are done. Have a good evening. Please do your homework.